The world's smartest AI researchers just admitted something uncomfortable. Scaling doesn't work anymore. Nvidia knows it. OpenAI knows it. Every lab pushing foundation models knows it. For a full decade, AI followed one ironclad law: bigger compute, better results. Double your computing power, improve performance by 20%. Pour billions into chips and training data, get proportional breakthroughs. That era is ending. We've hit a wall that no amount of additional compute can breach. Here's what gets lost in the hype. It's not that we've run out of ideas. It's that we've run out of efficient ideas. The scaling laws that governed AI since Transformers arrived are breaking down. We've extracted nearly everything useful from just making models larger. Returns are becoming painfully thin. But here's the twist arriving right now. Brain-computer interfaces are graduating from science fiction to actual patient trials. Neuralink's putting computer chips directly into human brains. It sounds like 2050 technology, but it's happening in 2026. The reason? Because the smartest minds in tech believe the next AI breakthrough won't come from bigger data centers. It'll come from building smarter bridges between human neurons and artificial intelligence. The remarkable part: the AI scaling bottleneck and brain-computer interfaces are two halves of the exact same story. As artificial systems hit their compute ceiling, companies are asking a radical question. What if the answer isn't smarter machines? What if it's enhancing human intelligence? To understand the bottleneck, you need to know what the last decade looked like. Imagine you're training an AI model like teaching a student. More books, longer study sessions, smarter tutoring, all improve outcomes. For AI, that meant more training data, more compute, bigger models, and it worked. GPT-2 was 1.5 billion parameters. GPT-3 jumped to 175 billion. GPT-4 went even larger. Each jump came with measurable improvements. Researchers called this the scaling law. There was a beautiful, predictable equation that mapped compute directly to performance. Executives loved it. Build a bigger cluster, get a better model, win the market. So throughout 2023 and 2024, everyone poured money into data centers. Nvidia's H100 GPUs were the hottest commodity on Earth. Energy bills for training runs reached millions of dollars per model. Microsoft, Google, Amazon, they all bet that raw scale was the winning strategy. But around mid-2024, something broke. Models got bigger, but improvements shrank. Your training cluster doubled in size, you got maybe a 5% performance boost instead of 20%. Then it got worse. Double the compute again, barely noticeable improvement. The equation everyone trusted stopped working. Researchers started whispering about saturation. The easy gains were gone. So what exactly is the bottleneck? The answer isn't one thing, it's three overlapping limits hitting at once. First, data. These models train on basically everything publicly available on the internet. We're not talking about millions of documents. We're talking about billions. Every Reddit thread, every research paper, every Stack Overflow answer, every book ever digitized. And we've already used the high-quality stuff. What's left is lower quality, niche, or repetitive. You can't train a smarter model on worse data. It's like trying to teach someone advanced physics by giving them coloring books instead of textbooks. Second, compute efficiency. Running a 100 trillion parameter model requires absolutely staggering amounts of electricity. We are talking about the energy consumption of small cities just to do inference, answering one question with a trained model. Cooling systems fail, power grids strain. At some point, bigger becomes physically impossible or economically absurd. Third, and most interesting, capability saturation. There's a hard wall on what pure scaling achieves. Current models plateau on reasoning tasks. They hit a ceiling on novel problem-solving. You can't just train a model bigger and expect it to suddenly understand quantum physics or invent new medicines. The neural scaling laws everyone trusted had a ceiling nobody talked about. We are pressing against it now. This isn't theoretical. It's happening right now in the real world. Anthropic released detailed research showing that beyond a certain model size, scaling provides almost no improvement on reasoning tasks. Companies like DeepSeek took the opposite approach. They built smaller, smarter models using novel techniques instead of just adding more parameters. Their result? Competitive performance with models that cost 5 times more to run. Meta faced the same issue. They noticed that training Llama required exponentially more compute for diminishing improvements. So they shifted strategy, better training recipes, smarter data curation, architectural innovations instead of brute force. OpenAI's facing it too. Each GPT iteration requires more compute than the last, but the jumps in capability are smaller than before. The honest assessment from insiders: we've entered an era where throwing money at the problem doesn't solve it. And this scares the industry more than any AI safety concern, because it directly threatens the business model. If you can't guarantee that the next model will be significantly better, why would anyone fund a billion-dollar training run? Startups that bet everything on bigger equals better are scrambling. Nvidia's data center revenue, the entire foundation of their AI success, faces an existential question. If companies stop building massive training clusters, what happens to the GPU market? Here's how the old strategy compared to what's coming next. The old approach was brute force: identify a scaling law, build bigger clusters, iterate. Simple, scalable, expensive. Nvidia and cloud providers got impossibly rich. The downside: if scaling breaks, you've bet your entire company on a curve that no longer exists. The new approaches are smarter but harder, better data. Instead of scraping everything, curators are selecting high-quality training material. This requires human judgment and costs more upfront, but the model learns faster. Novel architectures. Researchers are building models that think differently: mixture of experts, sparse models that activate only relevant parts, architectural innovations we haven't even named yet. Different training recipes, better optimization techniques, smarter learning rate schedules, training that mimics how humans actually learn instead of just grinding through data. All of this requires fewer computers than the old way, but more research. The comparison is striking. Old way, 10,000 GPUs, generic data, standard architecture. New way, maybe 2,000 GPUs, curated data, custom architecture. Same or better performance, lower cost, faster training. Companies that crack this win. Companies that stay married to scaling, they're about to become very expensive dinosaurs. What does this mean for the AI industry? Honestly, it means chaos, but in a positive way. It means the race isn't who builds the biggest model anymore. The race is who solves the right problem with the smartest approach. This benefits researchers over engineers. This benefits startups over trillion-dollar corporations. This benefits people who understand that intelligence isn't about size, it's about design. For users, this could be incredible. Instead of waiting for OpenAI to train a 10 trillion parameter model that costs $500 million to run, we might get specialized, faster, cheaper models that actually solve real problems. Medical AI for cancer diagnosis. Coding assistants that outperform giant models. The energy implications are massive. Data centers currently consume 4% of global electricity. If we build smarter models using less compute, we stop the exponential climb toward 10 to 15%. Climate and energy grids depend on this change happening, but there's a darker implication: only well-funded labs can do cutting-edge research. Startups get left behind. Winner-take-all dynamics might intensify, and this is where the bottleneck connects to brain-computer interfaces. That's where the real innovation frontier is heading. So what are researchers actually doing about it? They're exploring 3 concrete directions. First, better training techniques. Researchers at Stanford and DeepSeek have shown that you can squeeze 30% more performance from a model by just improving how you train it. Better learning rates, smarter optimization, training strategies inspired by neuroscience. Second, specialized models. Instead of building one giant model for everything, teams are building small models that do one thing brilliantly. This is harder to market. It doesn't sound as impressive as GPT-10, but it's more practical. Third, and this is the fascinating part, integrating human intelligence directly. This is where brain-computer interfaces enter the picture. Companies like Neuralink are betting that a human brain enhanced with a neural link can think faster and solve harder problems than any current AI. A researcher with a brain-computer interface might be able to iterate on AI research 10 times faster. A programmer could debug code using intuition and pattern recognition enhanced by AI. It sounds science fiction, but it's not theoretical anymore. Patient trials are active. People are using neural implants right now. The next big leap in AI might not come from bigger models. It'll come from augmented human researchers working with smarter, smaller AI. Here's what this all means for you. The AI bottleneck breaking the scaling paradigm is actually good news if you've been worried about artificial general intelligence spiraling out of control. It means unlimited compute can't solve every problem. It means we can't accidentally stumble into superintelligence just by spending more money. Intelligence requires design, subtlety, and probably human-like training rather than brute force. The brain-computer interface trials, they're the sign that AI's next chapter isn't about machines getting smarter, it's about humans and machines thinking together. In 5 years, you might see knowledge workers using neural implants to interface with AI tools, not science fiction. Just the natural next step when scaling hits a wall. For the industry, this means the era of bigger always wins is over. The next billion-dollar companies in AI will be the ones that figured out how to be smarter without being bigger. For you watching this, stay curious about these two stories. The AI bottleneck debate is reshaping which companies survive the next 5 years. Brain-computer interfaces are redefining what's possible for human cognition. They're not separate trends, they are the same story about intelligence's future. Follow for daily AI news, because these changes are happening faster than most people realize.